Hi, so welcome to today's video lesson. And today's video lesson, we're going to be talking about the area under a VT graph. So the area under a VT graph is actually the distance covered, the total distance covered. So let's look at this first case. Let's look at the first case. So this is the time axis measured in seconds. And this is the velocity axis measured in meter per second. Alright, so let's say that the object starts from rest. So if it starts from rest, it starts from the origin. So it's accelerating. Okay, so this is the acceleration. Alright, so it attains a particular velocity, let's say v, at a particular time, t. So from here to here, or better still, let me say from here to here is the t. Then this is the v from here to here. So now the question is, what is the area covered? So what is the area covered under this line? So now you see that this forms a right angle triangle, right? Good. So the area covered by this line is actually the area of a triangle, and that is how to find the distance covered by this particle. Now the area of this is actually half base times height, right? Half base times height. So if this was the base here, the base here is time. So that's t. What is the height? The height is v. So this is so s now becomes, total distance traveled now becomes s vt. So that's how to find total distance traveled in this case. All right, let's look at another case. Let's say b. Okay, then you have the time axis in second. Then you have the velocity axis in meter per second. All right, good. So let's say it starts from not from rest, from a particular velocity up. So that means it starts from here. Let's call that u, and then it stops at v. So what is going to be it does that for a particular time. Okay, it does that for a particular time. So what's going to be the total distance traveled by this object? So that has to be the area covered by this line. And if you look at this very well, what kind of shape is this? So it looks more or less like a trapezium, right? Good. A trapezium looks like this. So it looks like trapezium, right? Good. That's a trapezium. Okay. Now we know that this from here to here is actually u. This is u. Then all of this is v. Okay, good. And this is our time, t. Okay, so what is the total distance traveled? That will be the area of the shape. So area of trapezium. And I believe you should be able to remember the area of a trapezium from your geometric class, that half a plus b h, and that half was my a is u was my b is v, plus v was my height of the trapezium. This is my height of the trapezium, and that's t. So the total distance traveled by this is actually half u plus v t. So this is the second case, total distance traveled. Then let's look at the third case. So the third case looks like this. So this is time in second. This is velocity measured in meters per second. Okay, then you have let's see, just moves in a straight line this time around, in a straight line. So that means both u and v, so this is v, both u and v, they are the same point. So there's no starting point, there's no ending point on the velocity axis. So it's uniform velocity. So what's the time? So this is the time that it takes to actually travel, and so this is going to be the v, because that's the v. Okay, so what is the area covered by this line? What's the area covered by this line? So this is a quadrilateral, or maybe a square or a rectangle, as the case may be. So that's going to be length times breadth. That'll be length times breadth. Okay, and that tells us that the distance traveled has to be v times t, and so distance traveled has to be vt. So this is, in this case, the acceleration is 0 because there is no acceleration. So when in vt graph, when the graph is going like this acceleration, this is uniform velocity or uniform speed, and this is retardation. Okay, good. So in the next video, we're going to be looking at examples on how to solve distance traveled using these three cases that we have looked at. All right, good.